All right, so we're going to do a specific example of this orthogonal decomposition of vector v. Suppose we're given vector v is given to be I plus 3j. Vector w is given to be 4I plus 2j. And our task is to find v1 and v2 such that these three statements are true. v1 and v2 are orthogonal. We have v1 parallel to w, and v is the sum of these two vectors v1 and v2. So our task is to find v1 and v2. So that's what we're looking for. Okay, so this procedure is straightforward. Vector v1 is the projection of v onto w, and that process it's the dot product over the norm squared times another vector. Now remember, the only time vector v appears in this computation is at the very first spot. Everything else is the second vector w. So we need the dot product over the magnitude squared. Remember, the square of the square root just cancels. And then that's going to be multiplied by vector w. And vector w we know is 4I plus 2j. So what do we have? Vector v dot vector w is the dot product. That's product of the components 1 times 4 and 3 times 2. And then we need the magnitude of w squared, so that's 4 squared plus 2 squared. Square root squared cancels. And so we're left with 4 plus 6. Do we see that? 4 plus 6 is 10 over, this is 16 plus 4. 16 plus 4. 16 plus 4 is 20. And this is 4I plus 2j. So that's 1/2 times 4 is 2I. And 1/2 times 2 is 1j. So we have 2I plus j for vector v1. So vector v1 is the projection of v onto w. So vector v1 is the projection of v onto w, and so that is 2I plus j. Vector v1 is 2I plus j. And then the last piece is to find vector v2. And vector v2 is original vector v, which is 1, 3, or I plus 3j, minus vector v1 is what we just found. Vector v1 is 2I plus j. So that's I minus 2I is negative I. This is 3j minus j is plus 2j. I minus 2 is negative 1, and then 3 minus j is 2. So that's my vector v2, negative I plus 2j. And those are the two vectors we're seeking.